Hello everyone. The topic we are going to see now is nodal analysis for AC circuits. So let us see two problems based on node analysis for AC circuits. The first question: determine the power consumed by the 10 ohm resistor in the circuit shown using nodal analysis. So what are we asked to calculate? We need to find out what is the power consumed by this particular resistor. So in nodal analysis, before proceeding with any problems, we need to identify the principal nodes and the reference nodes. So principal nodes means any point where two or more elements are connected together, we call them to be principal nodes. And reference node means just like that I cannot find the voltages. So we need to define any reference node, like how we have a ground value in circuits. We need to define a reference node for every circuit in which we proceed with nodal analysis. So before directly going on to this problem, we will first see what are the steps involved in nodal analysis. So first we need to choose a reference node and we need to name all other nodes that are present. So we will determine one reference node for the circuit and also nodes where more than two elements are meeting at a common point. So those nodes also we need to find out. Next, using this we'll be writing a node basis matrix. As how we have in mesh analysis, in nodal analysis also we need to write the node matrix, and again we will use the same Cramer's rule to evaluate the matrix. So after writing the node basis matrix, we will find the elements of the matrix and we will solve the determinants to find what are the required parameters. So determine the nodes and the reference nodes, write the node basis matrix, find the elements of the matrix, find the determinants, solve using the same Cramer's rule we followed in the mesh analysis method, and using this we are going to find what are the required parameters. So these are the steps that we are going to follow in the nodal analysis method. Now let us start with the first problem for the circuit we saw already. Now if you see in this, there are two sources. There is one voltage source and there is one current source. Why I say this is given in volts and this is given in amperes. So this is given to be a voltage source, this is given to be a current source. So to simplify the analysis, we will try to make all the sources similar. I mean that if this is a current source, I'll try to make this also a current source rather than having two different sources. When all sources are similar, the problem becomes much more simpler for us to solve. So my first step, what I'm going to do, I'm going to convert this voltage source also into a current source so that the circuit contains all sources which are current sources. So I've kept the circuit here for a reference. In step 1, what we are going to do, we are going to convert this voltage source into a current source. So this is the step that we are following. The voltage source is connected in series with 3 plus J4 ohm impedance. These are called as impedances and just these values are called as resistances. Anything that contains a complex quantity. Complex value means what? It is A plus IB format. It contains a real part and it contains an imaginary part. So all these are called as impedance values. So here we have a voltage source connected in series with 3 plus J4 ohm impedance. So when you convert this to a current source, it becomes current source in parallel with the impedance. So always voltage source will be in series with an impedance value and current source should be connected in parallel with the impedance values. Now how to convert this? We will do source transformation. So applying Ohm's law, we know that V equal to IR or I is equal to V divided by the particular R value or the Z value. So V value is 100 angle 0 ohm, 0 volt and the impedance value is 3 plus J4. So I is equal to voltage value divided by R or divided by Z. It is the either way. Fine. So we can write that I is equal to V divided by Z as per Ohm's law. That is what we are following here. It is a voltage value divided by the impedance value that is present here. Now we can divide this directly in complex mode in your calculator, or you can convert this into polar form, and divide the two values to get what is the required current value. This simplification we will tell you when we have online classes. So those who know how to use your calculators, scientific calculators, keep your calculator in complex mode and divide 100 divided by 3 plus J4 directly. You will be getting this particular value for current. So now we know the current value. So how should I connect it? It is the current value in parallel to this given impedance value. So therefore, this circuit now gets transformed like this. So this part of the circuit, from here to here, it remains the same. If you see here, these both are similar. Till 10 ohm, till the rest of the circuit, it is same. But what has been modified? This voltage in series with the impedance has been now converted to a current in parallel with the impedance values. So we have just made source transformation so that the circuit contains similar sources. It contains only current source or it contains only voltage source to simplify our analysis. So in the first step, I've just converted the voltage source into a current source. Now we are done with this. Next, what we should do, I need to find out what are the nodes present in my circuit, and we need to define one reference node. So I'm going to take this point which is similar to ground. So I'm going to take this point as a reference node, and if you see this element, this 10 ohm and this 4 minus J3 ohm meet together. So I've named this common point to be the voltage point V1. Similarly here the 4 minus J3 ohm and this 3 ohm, these two elements meet together. So this we have named to be V2. So in this particular circuit I can identify two nodes which are V1 and V2, and we have one reference node which is defined here. Fine. So a principal node, this V1 and V2 is nothing but points where more than one element meet at the circuit. That is what we define to be the V1 node and the V2 node. Let's move on to the next step. Step 2. We are going to form the node matrix. So the node matrix is usually defined in terms of admittance. Admittance means it is Y. So I'm going to define the node matrix in terms of Y. So we saw that there are two node voltages. So two node voltages means it is a 2 cross 2 matrix. So it will be Y11, Y12, Y21, Y22 into two voltages V1, V2 is equal to, and what are the sources present in a circuit? There are two current sources. So we name it to be I11 and I22. I hope you're clear with this. Actually by Ohm's law we write that V equal to I into Z. Instead of R we use Z for impedance. But when you bring the Z to the other side, it becomes V into 1 divided by Z is equal to I. And the inverse 1 by Z is inverse of impedance. Inverse of impedance is what we call to be the admittance. So it becomes V into Y is equal to I, where Y is what we define to be the admittance term, which is nothing but the inverse of impedance. That is how we got this matrix. V into Y is equal to the I value. So this is also obtained from Ohm's law and nothing else. Fine. Right. Now after writing the node basis matrix, what are we supposed to do? I need to find the elements of this matrix. So I need to find what is Y11, what is Y12, what is Y21, what is Y22. V1, V2 are the node voltages that we have defined, so that will remain the same. And I11, I22 are the current sources present in our given circuit. So first let us start finding what is Y11. Y11 means the impedances or admittances, sorry it is not impedance, the admittances that are connected to this V1 point. So if you see the first point, this is getting connected here, this is getting connected here, and also this is getting connected here. So there are three values of impedance, which is 3 plus J4 ohm, 10 ohm and 4 minus J3 ohm. But we define this matrix as admittance. What did I tell admittance to be? It is inverse of impedance. So it will be 1 by 3 plus J4 plus 1 by this element 4 minus J3 plus 1 divided by 10. So we are considering all the impedances that are connected to this point V1. That is what we call to be the Y11 value. So once again you can use your complex mode in your calculator to find what is 1 by 3 plus J4 plus 1 by 4 minus J3 plus 1 by 10. We will get this particular answer. Fine. Now we'll go to Y22 and then come to the remaining two elements. What about Y22? It is the elements which are connected to the nodal point V2. So what elements are connected? This 4 minus J3 is connected here and here this 3 ohm is connected here. So it will be 1 divided by 4 minus J3 plus 1 divided by 3 and this gives our Y22 value. So we are done with Y22. Now what about Y12 and Y21? So Y12 and Y21 are the common elements connected to V1 as well as to V2. Now check the circuit. Which element is connected in common to V1 as well as V2? So if you see here, this 4 plus J3 ohm, this is connected to the point V1 also. This is connected to the point in common to V2 also. So Y12 or Y21 will be 1 divided by 4 minus J3. And common elements we represent with a minus sign as how we saw in the mesh analysis method. So it is minus of 1 divided by 4 minus J3 and therefore we get the particular answer. So it is minus 0.16 minus J 0.12. So I hope you're clear with this particular admittance matrix. Now what is I11 and I22? I11 is the first source connected to the first node. So it is 20 angle minus 53.13. So how do you calculate this angle value? It is cos of the angle plus J sine of this angle. So the magnitude 20 remains the same. So it is 20 cos of minus 53.13 plus J 20 sine of minus 53.13 and we are getting this particular answer. And what about I22? It is 10 angle 45. So it is 10 cos 45 plus J 10 sine 45. But if you see here, there is a minus sign. What might be the reason for this minus sign? The minus sign is not present for the first current source. It is only there for your second current source. The reason is, if you see in your question, if you see in the given question, this is the voltage source. So we will assume this to be the positive terminal and this to be the negative terminal, and we will start assuming that current flows through the circuit in this way. This is how we'll assume the current flow to be. In that case, from negative to positive means we will write the current value to be positive. But if you see this current source, it is in the opposite direction of your original source that is present here. So which means this will be the reverse one, which is minus of 10 angle 45. I hope I've made my point clear. So in the main source of the circuit, we will assume this to be positive, this to be negative, and we will assume that the current originates in this direction. So in that case, minus to plus means it is a positive. It leaves the positive terminal. So current will also be positive in nature. But this is in the opposite direction of that. So we will assume this current to be of a negative magnitude. So that is why we have, let me go back there. So that is why we have minus 10 angle 45, which is minus 10 cos 45 plus J sine 45. Fine. That is how we have got this. Now we have found the elements of the determinant. Now next step, we will solve the determinant. We'll fill up the matrix and we will solve the determinant using the same Cramer's rule. So I have filled up the matrix. This is Y11, Y12, Y21 and Y22. V1, V2 we need to find out. This is I11 and I22. In the question what is asked, we are asked to calculate the power consumed by this 10 ohm resistor. Now what is the power? Power value is equal to, it is V square divided by R, right? So R value is 10 ohm and we need to find out the corresponding voltage. This 10 ohm is connected to which voltage? It is connected to V1. So I need to find out V1 alone. So V1 square divided by R, that gives my required power value. So how to find V1? Find del 1. Del 1 by del gives our required V1 value. This is similar to what we solved in the mesh analysis method. So first find the determinant of this. This gives your del. They are represented as del dash because these are complex numbers, nothing else. You can have it as del also. So the determinant of this matrix gives us del. And what is del 1? We will remove this particular column and replace the current value in the first column. That is what we mean by the del 1 determinant. And V1 is nothing but del 1 dash divided by del. Now find the determinant of del. So this is the determinant of this particular value. So find the determinant. We are getting this particular answer. The next step what we are doing, we are finding out what is del 1. So we have replaced the first column with the current source values and we are getting this particular determinant. Now how to find V1? V1 is nothing but it is del 1 dash by del dash. So we are dividing the determinant del 1 value divided by del determinant value and we are getting this to be V1 value. Now what is the power consumed formula? It is V square divided by R. So V square is this value, the whole square divided by the corresponding resistance value. And one thing to note, it is modulus of V1 square. When we calculate power, no need to consider the direction value, consider the magnitude alone. So it is 62.412 the whole square divided by resistance value is 10. So the power consumed by the 10 ohm resistance, we are getting it to be 389.5 watts. Right? So this is how we find the voltages and the required other parameters using the node analysis method. Hope you are clear with the steps that have been involved. So it is very much similar to mesh analysis, but here we will identify the nodes and we will write the node basis matrix instead of the mesh basis matrix. So let us solve one more problem. So in the second question, we are asked to find the voltages across various elements in the circuit using node method. So various elements means this J3 ohm is one element, minus J5 ohm is one element, 3 ohm is an element, 6 ohm is one element. So we are asked to calculate the voltage across all the elements in the circuit using the node method. So now what is the first step? In the first step, we will find the various nodes present in the circuit as well as reference node. So let us start with that. So we are marking the nodes. So as usual, this we will mark it to be the reference node. And if you see at this point, this J3 ohm minus J5 ohm and 3 ohm are coinciding. So this we have named it to be V1 dash. And at this point, again J3 ohm minus J5 ohm and 6 ohm are meeting. So we have named this to be V2. And in this question, both the sources are current sources. So we are not performing any source transformation. Second step, we are going to write the node basis matrix. So again, two node voltages. So it is V11, V12, Y11, Y12, Y21, Y22 into V1, V2 is equal to I11, I22. What is Y11? So see this point. This is connected. This is connected. And this is connected. So it is 1 by 3 plus 1 by J3 plus 1 by minus J5. And we are getting one particular answer. I'm telling you the steps alone. I'm not telling you how to solve this value. Maybe try using your complex scientific calculator. If not, when we see our classes using Zoom or Google Meet, I'll tell you how to use the calculator also. And what about Y22? This is coming here. This is meeting here and this is meeting here. So it is 1 by J3 plus 1 by minus J5 plus 1 by 6, that is y22. And which one is common to both? So common to V1 and V2 is two elements are there. One is 1 by J3 and the other one is 1 by minus J5. But common elements will represent with a common minus sign. So it is minus of these two elements. We are getting this to be y12. And what about the two current sources? The first one is 5 angle 90, second one is 10 angle 0. So angle 0 means it is just 10 amps, no need to mention the angle. And if the angle is 90, it represents the imaginary value. So angle 90 can be represented as an imaginary part with this j into 5. So have this in mind. If the angle is given to be 0, no need to represent the angle at all. If the angle is represented as 90, it means there is no real term, only imaginary term is there. So we will write this as j with a value of 5. Angle 90 is nothing but a value of j. So it is j with an angle of 5. Right? Why this 90 is, maybe that too I can say. Angle of 90 is nothing but cos 90 plus j sin 90. Right. So cos 90 value is 0. Sin 90 is 1. So if when you write cos of 90 degree plus j sin 90 degree, cos 90 becomes totally 0, sin 90 becomes 1. So only this j term remains for us. So that is why we say angle of 90 is nothing but just j alone. The real term vanishes for us. So that is why angle 90 is just j. Now substitute all these values in the above matrix. So we are substituting y11, y12, y21, y22 into v1, v2 is equal to I11 value which is j5 and I22 value is 10. Now in the question we are asked to find the current through all the elements, I think. So we will first start by solving the determinant values, the voltage through all the branches. So we will first solve all the determinant values. We have two voltages V1 and V2. So V1 will be del 1 by del, V2 will be del 2 by del. So first find what is del. Del 1 means replace this first column by the current, second column remains the same. Del 2 means replace the second column by the current values, first column remains the same. Now calculate the determinant. What is del? Find what is del 1. Find what is del 2. Now V1 is nothing but del 1 by del. So divide the two values. We obtain what is V1. V2 is nothing but del 2 by del. Again divide the two values. We get what is V2. Now how to find the voltage through all the branches? So this is our given circuit. And if you see in any circuit, each and every branch or each and every line branch of a circuit will have different voltage values. So for example, for this I mentioned it as VA. For this branch it is VB. This branch it is VC. This branch is VD. This branch it is VE. And this branch it is VF. So we have A, B, C, D, E and F. 6 different voltage values in our given circuit. And we are asked to find all voltages VA, VB, VC, VD, VE and VF. We will see how to do that. Now, when you see here, VA is connected to V1, VB is also connected directly to V1. So VA and VB will have the same value of V1 which is 9.564 angle 134. Similarly, VC is directly connected to V2 and VD is also directly connected to V2. So VC and VD will have the similar value of V2 as 48.575 angle 31.7. But VE and VF are connected in common to V1 and V2. So, when such a common connection is made, then the voltage across these two elements will be the potential difference between the two nodes. Potential difference means this potential minus this V1 potential. So, this is going to be V2 value minus V1 value. So, VE and VF are common to the two nodes V1 and V2. So therefore, the voltage across these two branches will be the potential difference between the two nodes. So we need to find what is V2 minus of V1 and that gives your required potential for the branch VE as well as the branch voltage VF. So I hope I've made the point clear. So these elements are not connected between any branches. So VA and VB are directly connected only to V1. VC and VD are directly connected only to V2. But these two elements are commonly connected, and that is why we find the potential difference of the two nodes. So this is how we perform or we find the voltages using node analysis method. Hope this is clear to you. Thank you.